Hi, myself Chief Engineer Bikash Biswas. So I would like to discuss regarding the ME engine, MAN BMW ME engine, that is 50 to 90 ME C engine. So as you see the engine control system diagram, we can see the bridge panel which is connected to the engine control room. In the backup operation panel MOP B, the main operating panel MOP A, that is in the ECR panel we can see EICU A, EICU B, and the local operation panel LOP which is connected to ECU A and ECU B, and we can see ACU 1, ACU 2, ACU 3 and CCU cylinder 1, CCU cylinder n number of cylinders. So what exactly these items we would like to discuss? So I will tell you one by one, step by step manner, so that it will be convenient to understand. So the engine control system ECS is consists of set of controllers like EICU. What do you mean by EICU? EICU is the engine interface control units which handle the interface to the external system. Now ECU, the engine control units, perform the engine control function, the engine speed, running modes and start sequence. What is ACU? ACU is the auxiliary control units, control the pumps of the hydraulic system unit and the auxiliary blowers. CCU is the cylinder control units, control the FIVA valves, starting air valves and the main engine cylinder lubricators. And SCU is nothing but the scavenge control unit which controls both the exhaust gas bypass. It could be two types of exhaust gas bypass, that is for on off, or it could be a variable bypass which is used generally VT or variable turbocharging, but it is an optional. And MOP. What is MOP? MOP is the engineer interface to the engine control system. Now I will discuss regarding the normal working sequence from this diagram, how it is connected and which all components, what they are doing exactly in the ME engine. So the EICU, that is engine interface control unit, receive navigational inputs from the control station and select the active station based on signals given by the remote control system. The main navigational command is the speed set point, that is requested speed and direction of the engine rotation. In the EICUs, the raw speed set point is processed by a series of protective algorithms. This ensures that the speed set point from which the engine is controlled never harmful to the engine. An example of such an algorithm is the Baird speed range. Now the process speed set point and the selected engine running mode requests are available via the control network to be used by the ECU as a reference for the speed control and the engine running mode control. Now what is ECU? ECU is the engine speed control, requires that the amount of fuel is calculated for each cylinder firing. The calculations made by the speed controller initiated in relation to the crankshaft position so that the execution is started just in time to make the fuel injection. This is controlled by the tacho function. The output from the speed controller is a request for fuel amount to be injected for the next combustion. This request is run through the different protective algorithms, the fuel limiters, and the resulting amount of the fuel command is produced. Based on the algorithm of the selected engine running mode, the injection profile is selected. The timing parameters for the fuel injection and the exhaust valves are calculated and the pressure set point for the hydraulic power supply derived. Based on the user input of the fuel sulfur content, minimum feed rate, the resulting cylinder lubrication feed rate for each cylinder unit is calculated. The resulting amount of fuel command the requested fuel injection profile, the timing parameters, and the resulting cylinder lubrication feed rate amount are all sent to the CCU of the cylinder in question via the control network. Likewise, the hydraulic pressure set point is sent to all the ECUs. For redundancy purposes, the control system comprises two ECUs operating in parallel and performing the same task, one being a hot standby for the other. If one of the ECUs fail, the other unit will take over the control without any interruption. Now, what is CCUs? In appropriate time for the next firing, the CCUs ensures that it has received new valid data, whereafter the injection profile start angle is set up using the tacho function. On the correct start angle, the injection is initiated and is controlled according to the fuel amount command and the injection profile command. When the injection is completed, the exhaust opens and close angles are set up using the tacho function, and the exhaust valve control signal is then activated on the appropriate crank angles. The cylinder lubricator is activated according to the feed rate amount received from the ECU. All of the CCUs are identical, and in the event of a failure of the CCU for one cylinder, only the cylinder will automatically be put out of operation, running with cylinder out of operation. Now ECU. The ECUs control the pressure of the hydraulic power supply system and the electrical startup of the pumps using the pressure set point given by the ECUs as a reference. Furthermore, the start and stop of the auxiliary blowers are controlled according to the scavenge air pressure. The control of the auxiliary equipment on the engine is normally divided among the ECUs so that in the event of a failure of one unit, there is sufficient redundancy to permit continuous operation of the engine. Now, what is MOP? The main operating panel is the main information interface for the engineer operating the engine. The MOP communicates with the controllers of the ECS over the control network. However, the running of the engine is not dependent on the MOP, as well as the commands from the local control stations are communicated directly to the EICUs or ECS. The MOP is located in the engine control room. It is a PC with a touch screen as well as a trackball from where the engineer can carry out engine commands, adjust the engine parameters, select the running modes, and observe the status of the control system. A backup of MOP is also placed in the engine control room. Now, main engine start from local operating panel. In order to start, stop, and operate the main engine from the local operating panel, local control must be selected as the active control station. This is normally done via the request acknowledge facility of the remote control system. However, it is possible to override the normal changeover procedure by means of the force take command push button. Activating the button will force control to the local station. Now, the main operating panel is the human machine interface through which the engine control system and thus the main engine is operated. The human machine interface is nothing but a marine approved certified PC. This PC may be one of the two types, an integrated unit with touch screen or a standard PC. An actual installation comprises of two MOPs. Typically, one is usually used for MOP A and type 2 for MOP B, where both are placed in the engine control room. Each MOP may be any of the two types. Typically, MOP A is placed in a console opposite to the maneuvering handle and MOP B on a desk. The two MOPs are operationally fully redundant. Now, MOP A. This MOP type has no ordinary keyboards or mouse. Both may be optionally be equipped. A trackball typically replaces the mouse. A keyboard is essentially not required during normal engine operation, and a virtual keyboard is displayed in case textual input like password is needed. The touch screen is a frame in which an infrared grid is used for detecting touches to the screen. The operator doesn't need to actually touch the screen as the grid is displaced from the screen surface. Instead of traditional use of a mouse, the operator touches the graphic elements of the screen in order to interact with the ECS. Now, what about MOP B? MOP B is based on the standard PC technology and with a keyboard, mouse and CD-ROM drive. So MOP-B has connection with the Ethernet. Only MOP-B may be equipped with an Ethernet card for connection to the other system like such as COCOS EDS, means computer controlled surveillance engine diagnostic system. Special care must be taken when connecting to the network of any kind to avoid virus and worms on the MOP. Now let us go to the MOP panel for better understanding. So we are going to the MOP panel, exactly the sections and how it will look step by step for better understanding. So we have come to the MOP panel, the first screen. So we will discuss this screen and we will go one by one. So in the MOP panel, that is the HMI, human machine interface, it is 4 fixed areas. We can see what are those. That is an alarm status bar. In this diagram you can see the alarm status bar showing the oldest non-acknowledged alarm and alarm status at the top of the screen. Okay, a navigation bar at the right side of the screen. There is a navigation bar at the right side of the screen, a toolbar at the bottom of the screen, and a screen area rest of the screen. The HMI operates with 2 password level, which are operator level and the chief level. So we can see below the power off button the access, where a human figure is there. Where you press, there is access. The access is given by a password, which there are 2 level, that is operational level and the chief level. Now what is operational level? Operator level. From the operator level, it is not allowed to see any parameters, to set any parameters. From the operator level you cannot set any parameters. It is only for monitoring purpose. And there is another level that is called chief level. So I know this is given only for the chief engineers, and so they can interact with this MOP and they can adjust the parameter and set the process. So in addition to the operator level, the operator has privilege to set the parameters like set point, engine states and engine modes, etc. A password may be supplied in order to access chief level. There is no limit in the number of unsuccessful attempts to enter the correct password. The password is hard coded in the system and can be therefore not be changed. So what is the password? Bad weight, BADWOIT, bad weight, that is used in this system. Alarm system. The alarm system displays on the MOP panel are all related to the ME engine control system and thereby surveillance of the engine condition. Now the ordinary alarm system and the ME ECS alarm systems are connected and able to interact. So this is caused by the use of common sensors for engine monitoring. That is, common sensors are used for indicating and detecting alarms as well as slowdown. Especially alarms interacting with the engine safety systems are common for the engine control system and the ordinary alarm system. As an example could be mentioned alarms giving slowdown or shutdown. When a slowdown has been detected by external slowdown function, this is signaled to the ECS by binary signal. When the binary signal is high, the resulting speed set point is forced to the preset slowdown level. Now alarm handling. What we have? Alarm handling is carried out from one of the following 4 screens. When you press the alarms, so we have seen the right side the navigational bar, we have alarms, we have engine, we have auxiliaries, we have maintenance, then admin, then power up, then access. And on top we can see the noise space blower feedback from ACU 3, and this is the top, and the right extreme right corner we can see the red color 18, then yellow color 12, then blue color this 48 and 0. So these are the details about the unacknowledged alarms, which are in the alarm states, which the alarm have become normal, like that. And at the extreme bottom portion we have this toolbar where acknowledge all this cut out like this, and screen up, down, value up, or value down, etc buttons are there, info buttons are there. So basically alarm in the alarm button, when you press, we have 4 button which will pop up, that is the alarm list, event log, manual cutout list and channel list. So these 4 alarm handling screens can be accessed via the secondary navigator by pressing the alarms button in the main navigator. When pressing this button, the latest selected alarm screen will be shown on the screen. If no screen has previously been selected, the alarm list is shown. So the screen can be changed via the secondary navigator. Now alarm list. So what we get from the alarm list? The alarm list contains the central facility of the alarm handling, allowing for display, acknowledgement and cutout of raised alarm. So what we can do from this screen, as the screen depicting now, we can either acknowledge the alarm, we can cut out the raised alarm, and detailed explanation also can be accessed from this screen. How to do that? The alarm can be grouped to simplify the overview of the alarm list and are displayed in chronological order with the latest alarm on the top. So latest alarm will be displayed on the top of the screen. The group can be expanded by selecting a group and pressing the minus and plus button. There are minus and plus button. So group can be expanded by selecting the group and by the minus and plus button. So if there are too many alarms to be displayed at the same time on the screen, the remaining alarms can be accessed by presenting the page up and page down. That is page up and page down. So with this, by clicking the mouse, we can display the alarms. So alarm presented in the alarm list can be found in 3 states. The alarm can be found in 3 states, that is alarm non-acknowledged, alarm acknowledged, normal non-acknowledged alarms. So three types of alarms are there: alarms which is not acknowledged, alarms which is acknowledged, and normal condition, the alarms which have become normal and it is still non-acknowledged. So an alarm can only appear as one line in the alarm list. An acknowledged alarm going into normal or an alarm changed to normal being acknowledged is immediately removed from the list. So the alarms which have already become normal, so that will be removed from this list. Acknowledgement of a single or all alarms is allowed on both levels. So that can be done from the operator or from the chip level, from the acknowledge all button. So we can see acknowledge and all on the tick mark given. So if you press acknowledge and you select some alarm, it will, the individual alarm will get acknowledged. But if you select all, the all alarms which have been become normal, that will get acknowledged. Now to see a detailed alarm explanation, press the relevant alarm line. So we have to press the relevant alarm line and the description will pop up. So in the description panel, we can see the description, the cause, the effect and the action. So suppose one alarm that was in the list, and if you have pressed it, for example, no SPS blower feedback from SU3, that was the alarm, and you press this one. So group hydraulic SP pump failed on SU3. What is the description? The hydraulic high pressure pump does not work correctly, cause the hydraulic pump failure or MPC not running in normal mode or network failure. Effect, switch plate moved to the fail-safe position, that is the maximum flow in the ahead direction and running ahead. No effect on the engine performance. Hydraulic pressure may increase. Running astern and the reversing the engine may not be possible due to insufficient hydraulic pressure. So action, what action you will take? Check other alarms to locate the root cause for the pump alarms, that the MPC is in normal running mode. So like this, the alarm line, fields, colors and symbols, each one you have to take care. Now what do you mean by ACK? Acknowledge. This is acknowledgement status field of the alarms, contains an icon toggling between the two states, alerting the operator of a non-acknowledged alarm. Now in the red color and with the exclamation sign in it, non-acknowledged alarm in alarm state. If the exclamation sign and with a green color, non-acknowledged alarm in normal state. And if there is a uh, sandwich and in yellow color, the non-acknowledged alarm in alarm state waiting to be acknowledged. So these are the state. So we have gone through the alarm list. I think it is pretty clear. Now we will move to the next event, that is event log. If you press the event log, a screen will appear like this, as you can see on the screen. So we will discuss this screen. So the event log is, for instance, used for viewing the history of events and to support the operator in the troubleshooting. Event log means a series of events, how it has occurred. Events stay in the log even after they have been acknowledged and are no longer active. Now alarms are logged with 3 events in the event log. The events are alarm, normal and acknowledged. So there can be up to 1 million events logged in the event log. The events are stored in a database on the MOP's hard disk with both local and UTC timestamps. If more than 1 million events are logged, the oldest events are discarded. So we know what are there in this screen. ID tag unit, as you can see in the extreme left hand corner on the top, this ID tag unit, this is the field contain unique event identity. Then we have the date, we have the time, we have the description and we have the MCO. What it shows the alarm is manual. MCO means this is manual cutout or not. So sometimes they do manual cutout of alarm, and ACO means automatic cutout, and ACK means this is acknowledged. So whatever things we do with this interface and whatever has automatically happened with the engine in the event log, chronologically it will come and we can identify. So searching for an event from a specific date, time or by tag number, we can do it. This feature might be helpful information for external parties. When scrolling up or down on the event log screen is not sufficient, it is possible to search for a specific event log by tag number or pressing the tag button. So that is all. So event log we have described. Now if we go to suppose event log, they are describing how is this. If you see, suppose you want to find out some information, so you can use this unit tag filter, time span filter, or go to date time and put this information and you can find out when that event was happened. And same thing in this screen, also same thing in this screen. So we are going to this screen now, manual cutout list. What is the manual cutout list? When was the manual cutout was applied, and list of that. Manual cutout of the alarms may be used, for instance, if the engineer has observed a failure of a sensor that is not detected automatically. For example, a tacho pickup is failing, the engine running on the redundant tacho system and is continuously giving an alarm. So in that case, you cannot, this tacho system what has failed, you cannot replace it immediately, and in that case suppose you manually cut out this and continue to operate the engine, so this will come in the manual cutout list. Now automatic cutout may be used to suppress alarms which is unimportant in specific states, when the engine is stopped or when a sensor is detected as being faulty. Now manually cut out alarms are shown in a separate list which can be accessed from the navigation bar. Now manual cutout list, also we can see the topmost position in the right hand corner. We have seen an alarm. Manually cutout alarms are shown as a separately, which can be accessed from the navigation bar. The manual cutout screen is in a functionality equivalent to the alarm list screen, and alarm can be cut out manually from the screen alarm list manual cutout list. So we can see manual cutout list, and we can press manual cutout list or channel list, and alarm channel have status. Manual cutouts are shown in the manual cutout screen. Now removing, suppose we want to reactivate or we want to bring it in normal condition, then what we have to do, it is done by highlighting the alarm, select the alarm, and then you press the reactivate button in the toolbar. So that is how you can do this manual cutout list. And now we are going to the channel list. What is the channel list? Channel list is the alarm channel screen contains status information of all alarm channels within the ECS, no matter the status of the individual alarm channel. As default, the alarm channel are listed in the tag name in the alphabetic order from the alarm channel screen. It is possible to cut out alarm channel. Now let us go to the engine. That is the most important. Engine, if we press engine, so we can see in the navigation bar, that is the right side, we have status, we have process information, we have process adjustment, and we have the chief limiters. And now step by step I will discuss what are the function of this. Screen 1.1 and 1.2 are related to the engine startup and preparations and daily running, and like these two screens, these are important for startup preparation and daily running. And screen these and these are important for engine adjustment. Now let us go to the first screen. Okay, the first screen here, the operator can access these 5 operation and adjustment screen via the secondary navigator by pressing the engine button in the main navigator. So on screen, the display which can be activated are shown in the 3D graphic, and inactive displays are in the 2D graphic. Now operation, if we press the operation button, the operation is in the main screen for control of the engine during voyage. This screen is active most of the time between the engine ready, right from the engine ready to the finish with engine. So in between, this screen is used tremendously, and most of the time this screen is used. On this screen, prepare start. So we have here the prepare start. This screen you can see in the operation, we have the prepare start and the slow turn. Slow turn can be performed before the start of the engine. So this shows the full screen in the following a detailed description. Now main state. The main state field contains 3 status field indicating the current, sub telegraph command states, and the states of the engine. The background colors of the graphics are associated blue, that is the normal state, yellow warning state, red alarm state, and gray or dimmed not in use. Now the top field indicates the finish with engine, standby, or at sea. It is the main state. Like here you can see standby. So here you can see another 3 things, that is that there can be only 3 status of the engine, that is finish with engine, or it is in standby state, or it is at sea. So in the middle field indicates the states of the engine. Now we can see the command, that is the The command indicator button contains 6 or 8 status fields, 2 fields highlighted indicating the current active control station, that is breeze, ECR or LOP, and the actual speed command setting for each of the control stations. The actual selected control station is indicated by dark blue. The normal selection or yellow take command civil. Now the breeze control and engine control room stations are part of the RCS remote control system. Only one control station at a time is active. The active control station is normally selected via the RCS request acknowledge system. However, the selection may be overridden from the either the ECR or LOP by the take command buttons, which are wired directly to the ECS engine control system and situated on the control station panel. If the active control station selection is inconsistent, the ECS keeps the last valid active control station as the active station until a new valid selection is available. In the event the take command signals from both the ECR and the LOP are selected simultaneously, the LOP has the first priority and is selected. Now we have the RPM fine adjustment. Where is that one? Yes, command RPM fine adjustment. Okay, so these are coming under Indian operation. So RPM 5, like in this screen, see in the button when you press the operation, you can see a screen like this under the heading engine, and you press the RPM, where in the RPM set point you can by pressing the command RPM button. The command RPM button, where in the ECR, if the mode is ECR, the command RPM button, you press this command RPM button. So by pressing this button, it is the right side of the standby button. So you press this button, command RPM button, press the command RPM button, the RPM fine adjustment toolbar is displayed. This toolbar is appeared that has appeared at the bottom of the screen. Whereas the toolbar displayed, it allows the RPM set point to be adjusted in the operator level. That is, if the speed command set point is 183.8 RPM, it can be finely adjusted to 184. Moving the handle will disable the fine adjustment mode. Maximum fine adjustable speed can be adjusted if you are predefined number of the RPM. Note, RPM fine adjustment can only be performed in ECR command mode. So now running mode or governor mode. Running mode and governor mode. We can see running mode and governor mode in this screen. So the engine running mode and governor mode buttons each contains a status field indicating the current active running and governor mode. Let us discuss this. Changing the running mode is done by pressing the running mode button. What will happen if you press this running mode button? So you can see there are 3 buttons will pop up at the bottom of the screen. You can see economy, emission, then turbocharger cutout or custom. So if only economy mode is available, the mode selection is not usable, that is dimmed. The governor mode, now if you press the governor mode, the 3 governor mode has got 3 control mode, that is RPM control mode, torque control mode and index control mode. So pressing the governor mode, you can have RPM control mode, torque control mode and index control. When you press the governor mode, a pop-up window will appear at the bottom of the screen where you can find these 3 RPM control, torque control and index control. You can select any one of them when you have accessed in chief mode the system. Now you have got the pressure indicator. The pressure indicator consists of a bar graph and a status field. Then you have the auxiliary system status indicator, and the system status indicator display information of the operation mode of the auxiliary system controlled by the MECS. These are all indicators and do not allow changing mode or status. Possible control is made on the panels for the actual system. Indicators are HPS, hydraulic power supply unit. So here in this screen you can see the auxiliary system status right below the running mode and governor mode. Start here, then inlet oil, hydraulic oil, scavenge here. So HPS, hydraulic power supply unit, then lubricator. Let me go to that slide. Hydraulic power supply, manual or auto. Where is that screen? HPS. Yeah, HPS, here it is showing right below the start here, the HPS. It is showing auto, the lubricator showing stopped, and auxiliary bullish. That has two conditions, either it is auto or manual, and whether it is stopped or running. Now HPS is hydraulic power supply. It can be in two mode, that is manual and auto. The lubricator running or stopped condition, or it could be in the pre-lube LCD load change dependent on, and the PTO the power. The auxiliary blower, they represented by the two status field. One indicates on the operation mode, which can be auto or manual. The other indicates the current status of the blower, which can be stopped, starting, running, or failed. So these are the things. Then we have the speed RPM. Right side, we click this, then the speed indicator consists of a bar graph. The bar graph is centered at the 0, and positive and negative is up and down respectively. So the set point and the actual running speed of the engine are shown in the two display above the graph. The uppermost display is the speed command modifier. Uppermost display is the speed command modifier. The speed modifier is a function that may override the actual speed command and control the speed system set point for the engine speed. When the function is active, the control mode is shown in the speed indicator. So these are the things. Here it is showing stabilizing, like speed RPM, speed modifier. These available modes are stabilizing, stop, minimum speed, maximum speed, fixed speed, shutdown, slow down, speed ramp, load program, bird speed range, RPM fine adjustment, run up and down program, chip maximum speed, and turbocharger cut out mode. So these are the things. Now we have the fuel index indicator. The fuel index indicator consists of a bar graph and a set of status field. The top of the status will indicate the current effective or nearest limiter. The electronic governor will limit the fuel index command according to the actual engine operating conditions. If no limiter is currently active, the nearest limiter is displayed on a light blue background. When a limiter is active, it is displayed on a dark blue background. Available limiters are start. The start limiter defines a fixed amount of fuel to be used for the first injections during start. Chief. The chief limiter defines a maximum amount of fuel to be injected according to the settings done by the operator at the screen cylinder load. Scavenge air pressure. The scavenge air pressure limiter defines a maximum amount of fuel to be injected based on the actual scavenge air pressure in order not to overfill the engine. Torque. The torque limiter defines a maximum amount of fuel to be injected according to the actual engine speed. This is to ensure that the engine torque doesn't exceed recommended levels. The limit is defined in the load program. Hydraulic power supply. The hydraulic power supply pressure limiter defines a maximum amount of fuel oil to be injected according to the actual hydraulic power supply requirement in order to ensure that the hydraulic power supply pressure doesn't drop below a minimum operation limit. This limiter is only active in case of malfunction of the SPS and turbocharger cutout. If the turbocharger cutout option is installed, the fuel index will be limited when the engine is running on turbocharger cutout mode. So these are the limit we have seen. Now for the prepare state button we can discuss. The prepare state function is normally to be activated before start. If the engine has been stopped for some time, pressing the button will start the cylinder pre-lubrication and the auxiliary blowers. If the auxiliary blowers are already stopped, then it will start and the lubrication pre-lubrication will also start by pressing this prepare start button. But when pressed, the button will stay down until the procedure is completed. So if you press this, a set procedure will start and procedure will automatically completed, and after completion it will become normal. The command is available only when the engine is stopped and the prepare start procedure is not running. Then we have the slow turn button. So in the slow turn button, manual slow turn is used during preparation before the start of the engine and is normally to be used with the indicator cocks open. Slow turn is used for visual inspection of the blowout. When the button is selected, the engine is operated on starting air through the slow turn valves as long as the control handle is activated. So as long as you press the slow turn button, so the engine will slowly turn and you can see any liquid coming out from the indicator cock. And there is auto button. When you use this auto button, the auto button is pressed when start preparations are completed and the engine has to be started. So after the start preparation, everything is completed, you are satisfied with your preparation, then only you press this auto button. Engine is ready in all aspect. When selected, the engine will perform a normal automatic start. So if you press this auto button, engine will perform a normal automatic start. So air run button, the air run button function is only available in chief level. So when we press this air run button, the air run button can be used in case to check the tacho system test. That is the starting air tacho system test, starting air valve test, and after maintenance and after check with the turning gear to check the function and movement. Air run function is similar to the slow turning except that the main starting valve is open and the engine is running faster. Still, when you press the air run button, there will be no fuel injection. So when you need to blow through, you can press this air run button, the telegraph put in the standby mode, and then move the telegraph to the dead slow ahead position. So engine will turn by air, but there will be no fuel injection. And bring back the telegraph lever to the stop position, and then you can change this auto button air run button to auto button. Air run button you make it normal and press the auto button, and then you start the engine will start in fuel. So slow turn and air run are activated when the handle is in run position. This will rotate the engine until the handle is set to stop. Now we are going to the status button. So it is under the engine. We want to know the status, so we have to go to this status. We can see this screen will appear. So let us discuss this screen. This is very important. The engine status screen provides extended engine information specifically for use when changing the status of the engine, that is the process from finish with engine to standby state or vice versa. The main state field shows exactly the same information as the main state field in the operation, like start condition. The start condition field is a status list showing whether the engine is ready for start or not. The condition shown with a green checker mark must be present before the starting of the engine is possible. If a condition is shown with a red background and a white exclamation mark or an exclamation mark on a yellow background, the engine is not ready for starting. So this is the condition. So we have to check in this screen, no any red, no any yellow or any white, it should be in the blue background. If the condition is not relevant, the background is dimmed, but a check mark or exclamation mark will still indicate the status of the condition. The possible status indications of this field are what will be the conditions. The main starting valve in service position, standby or at sea. Yellow when the main starting valve is not in service position, green when the main starting valve is in service position. So these are the things you can check: main starting valve, the distribution system, then start air distribution system, starting air pressure, control air pressure, turning gear disengaged, auxiliary blowers condition, hydraulic power supply, hydraulic pressure, all will come. So one by one you have to check whether they are okay or not. Now after that, just right side of this main state field, the starting air pressure indicator displays the system starting air pressure continuously. Then we have the turning gear. There are two states, whether it is engaged or disengaged. Then control air pressure. The control air pressure indicator displays the system control air pressure continuously. Then we have the blowers. We can see the status of the blowers, whether it is running or not, and we can see the hydraulic oil pressure. Blower could be stopped running, starting, or failed. The hydraulic oil pressure indicator displays the system hydraulic oil pressure continuously. And crankshaft position now shows the current position of the crankshaft when turning the engine for maintenance purpose with the turning gear, and allows checking of the position in case of the malfunction of the starting air valves. When the engine is running, the field display shows the actual RPM. So here we can see all these things. Now start status indicator. The start status indicator consists of a single field containing information on the current start status. 3 successive start attempts failure or a slow turn failure will cause the start block. The below conditions are indicated: the start status of the indicator: stopped, running, repeated start, that is warning, slow turn failed, alarm, and start failed, alarm. So these conditions can be seen from this screen. Now we can see a pneumatic diagram in this screen, that is the starting air diagram. What we know about this, in addition to the information, now the diagram is intended to indicate the functionality of the system. There are pilot valves, you can see in this diagram, pilot valves A, B, and slow turning can and must be activated to test that the main starting valve and slow turning valve open and tightness of the air starting valves in cylinders. Pressing the field encircling the pilot valves opens a toolbar. Now you can see in this screen, if we press this, pressing the field encircling the pilot valves, the toolbar is popped up down below the screen, where we can see open main start pilot valve A, open main start pilot valve B, open slow turning pilot valve, and close valve. So we can open these pilot valves, which will activate this main automatic air starting valve or the slow turning valve, and we can check these valves, and we can close also from this screen. Now process information, we go to process information. If we press this process information, the screen will pop up like this. The screen gives user a quick overview of the possible limiters or governors used. The screen always shows the values currently in the use. Now what are the mode? The running mode, this field is the same as described in the running mode, and the governor mode field. And engine running mode is based on an algorithm which continuously determines the fuel injection and the exhaust parameter that influences the cylinder process. By controlling the cylinder process, maximum cylinder pressure, compression ratio, and blowback, fuel efficiency and emissions can be controlled to a certain extent. For the ME engines, several running modes may exist. These contain different algorithms and provide various fuel efficiency and emission characteristics. The running modes are configured for each engine type by MAN BMW. Now below that we have the speed control. The field is same as list of the speed modifier described in earlier section. Then we have speed set point RPM, fuel index set point, hydraulic oil set point, scavenge point set point, variable this exhaust gas bypass set point, and on off exhaust gas set point. What are the status of this? All this process information we can see from this screen. The speed actual RPM is 184.6, that we can see the actual set point. What is the hydraulic oil actual pressure and hydraulic oil set pressure, then actual this thing scavenge pressure. So everything can be there. Now we go to the next slide, that is the process information. Now process adjustment, process information. Process information also, the other slide it shows various condition. Now we go to process adjustment. This is the most important slide, and we have to know. So let us discuss this one. Process adjustment. In the chip level, the operator can adjust the balance of the engine related to MIP and fuel oil properties. So chief level, so you have to go to the chief level, and of course the operator can adjust the balance of the engine related to the MIP and fuel oil properties. So guys, there can be changes in the fuel oil properties each time you take bunker, and also your engine characteristics might be changed. So you can adjust the engine from this process adjustment. If you press the process adjustment in the chief level, the operator can adjust and balance the engine. So what are the section we have? If you press this, we have on the top horizontally, you can see auto tuning, cylinder load, cylinder pressure, fuel oil quality. So let us go to the auto tuning. What happened with this auto tuning? If you press auto tuning, automatically you come to this screen, and you can see the PMI auto tuning system is an optional function and is designed to help achieve a balanced running of the engine with the desired maximum pressure, that is Pmax, compression ratio Pcomp, and mean indicator pressure PI, according to the ordered ME ECS, that is engine control system. engine mode and engine load correct adjustment of the mean values will give a better fuel economy, while adjustment of the balance can give reduced cost of the maintenance. Now index stable, we can see sufficient sensor value status PMS deviation. Okay guys, now go to the next one, cylinder load. If you press this cylinder load, so suppose you will have to do auto tuning, you can do auto tuning, press this and press this auto tuning button on. Either you can do individual cylinder, you can check for all, select all, and then it will be done. Now if you go to cylinder load, the high load offset and low load offset, so in chief level the operator can adjust the load limit on one or more cylinders, adjust the cylinder load balance, as well as cut out. You can balance cylinder load, or you can cut out one or more cylinder units. Before taking a cylinder out of operation, check with the manual that is written in the section 70404, and this information must be taken into consideration. The operator can adjust settings on each individual cylinder. And cylinder pressure, if you press the cylinder pressure, you will get a screen like this. So you can change the setting of the maximum pressure level and balance the compression ratio, exhaust valve opening time, and combine into single screen view of the called cylinder pressure. So if you see chief level, the adjustment ranges are given, like Pmax adjustment level is given from plus minus 20 bar, compression ratio given from plus minus 2, and valve timing is 0 to minus 2 degree earlier than the engine mode requested value. So all this you can do, and you apply, and just press the required button that you want to change, either Pmax or P compression or exhaust valve opening time, whatever, press it, and you either you can check for all, or you can do individual units, you can select, and then you can increase, decrease, or then press the apply button, it will apply. Now we go to the next slide, that is, suppose what is there, cylinder pressure. So cylinder pressure also same thing as we have discussed right now, and now we are going to do the fuel oil quality. This is very interesting guys. Every time you take bunker, and after you get the analysis report as soon as possible, the calorific value, this is lower calorific value, could be changed. So accordingly you put the lower calorific value and density at 15 degrees Celsius. These two if you put, you will calculate the fuel oil quality offset, that will be automatically calculated, and that new fuel oil quality offset whatever you get, you will have to change, you have to put the new value, whatever the current value was there earlier, and you have to put it, and you press the save button, so it will be applicable. So on this screen, function for in, or that is decreased fuel oil index, that is the increase or decrease, whatever it is, for all cylinders the fuel oil quality adjustment is available. In case of poor fuel quality, so the specific calorific value and the fuel oil density must be checked in actual fuel oil specification delivered with the fuel oil samples at bunkering. Now guys, we are going to do, so from here we are same thing, and now chief limiters, very important slide. So chief limiters, what are the limiters? We have maximum engine speed. So chief engineer want to put a limiter for the safety of the engine, that is maximum engine speed. Manual limitation of index at all cylinders, also or cutout of one or more cylinders. Status of all SU, and is able to reset SU in case of failure. So by pressing the chief limiters, we will come across all these things, that is maximum engine speed. We can see view change and manual limitation of index at all the cylinders. Manual limitation we can put for the individual cylinders or all the cylinders, and we can cut out one or more cylinders, and we are able to see all the HCU, that is hydraulic control unit, and is able to reset suppose if there is a HCU failure. So in a chief index limit percentage, the pressure down the cylinder bar graph involved. Suppose you press this chief index limit bar graph, this is current, what is the current value and what is the new value as per the desired, then you can put change that one by increase or decrease, then apply, then it will happen the chief index this one. And the chief index percentage pressure down, press down the cylinder bar graph involved. A toolbar at the bottom of the screen allows the operator to limit the fuel injection on the chosen cylinder. When the cylinder is to be re-enabled, the bar graph of the cylinder involved is pressed down and the fuel injection is raised to the previous value using the arrows on the toolbar followed by apply button. So guys, this is clear. Now also the chief limiters you can see here. Exhaust valve operation enable, ECU status, that is normal. So chief index limit, here selected cylinder number 1 and the current value is 110. New value he can increase decrease from here to a save value, and he can apply save, it will save. Then again chief value, this exhaust valve operation enable. So exhaust valve of cylinder enabled or stop, so you can check that. And then there is ACU system status, you can see in this normal fault for second unit number 2. So you select this unit number 2 fault area and you can reset it from here. Now guys, go to the auxiliaries. In the auxiliary section, the hydraulic system, scavenge air, exhaust gas bypass if installed, and the cylinder lubrications are monitored in the auxiliaries main navigator. So from each menu the operator can control and monitor these systems: the screen or hydraulic system, the scavenge air or exhaust gas bypass system, the cylinder lubrication. So under auxiliaries there are 3 main category we are able to control, that is the hydraulic system, that is the scavenge air system including the exhaust gas bypass system, and the cylinder lubrication. So the hydraulic system, what we are going to do in the hydraulic system, so we press the hydraulic system, the screen shown over here will appear and we can control following things. The screen shows a simple schematic drawing of the hydraulic system. The screen shows from 3 to 5 engine driven pumps depending on the engine layout, and 2 electrically driven startup pumps. A bypass valve from pump pressure side to suction side is also shown, so you can see it. The following buttons are also be activated directly from the screen in chief level. So what are those? So we can see the SPS mode, that is hydraulic power supply mode, the pump torque limiter, the set point, and the bypass. So SPS mode guys, SPS mode has 2 mode. Pressing the SPS mode button, you can see SPS mode in auto. So it is basically auto and manual mode. In auto mode, it is possible to perform the following commands: both operator and in chief level. Select one of the electrically driven pumps as master. There are 2 electrically driven pumps, so you can select one of them as master. Select one of the engine driven pumps as pressure controlling pump. And in the manual mode chief level, the additional command features are the adjustment of the current hydraulic pressure set point, adjustment of the current hydraulic pressure set point. So you press this hydraulic pressure button where the pressure 183 bar is showing, 184 bar is showing, that is the set point. You press it, the pop-up window will appear. This screen you can see, if you press this set point 207 bar, it is showing. If you press this one, the pop-up window will appear where you can see the current value 207 bar and new value you can increase or decrease, and then you can apply this button. This will appear. Now operate the engine driven pumps bypass valve using either SU1 or SU3. Bypass valve to be tested for movement every 6 months at a stopped engine condition. Start stop of the electric start up pumps. So you can do all these function, guys. If for some reason automatic control of an engine driven pump cannot be maintained, the pump's wash plate is deflected to 100% in the full head direction only. Now guys, the pump torque limiter. Pump torque limiter, why it is given? It is possible to cancel the pump torque limiter in the chief level. The torque limiter has two functions. What are these? The total torque to the engine driven pumps must not exceed a level that can harm the gear and chain. So you understand. So pump torque should not exceed a predetermined level because that can harm the gear and the chain. Hence, to protect gear and chain, the sum of the wash plate position must not exceed a predefined value. That depends on the engine specification. To protect the individual pumps from breakdown or damage. To summarize, why this torque limiter is given? To protect the individual pumps from breakdown or damage, or to protect the gear or chain, the sum of the wash plate position must not exceed a predefined value. Now by pressing the pump torque limiter field, a toolbar will appear. Now let us see that. Where it is, this screen. This screen you can see pump torque limiter. If you press in the bottom of the screen, pump torque limiter has to be activated and cancelled. So a toolbar will where the limiter can be either activated or it can be cancelled. Cancellation of the limiter will raise an alarm on the MOP. So guys, when you will cancel this one, the limiter, then in case of high torque, this limiter will not get activated and you will not get alarm. So that will break the pumps and it will be harmful for the engine, gears, chain, etc. So be careful with this. By pressing the pump torque limiter field, a toolbar will appear where the limiter can be either activated or cancelled. Now, when the limiter is cancelled, the electrically controlled wash plates in the pumps are allowed to deflect to the mechanical limitation. Now what is going to happen? Electrically it is not going to now limit the pump wash plate. So it is not protecting the pump, and the pump will go, the wash plate will go up to the mechanical limitation. It can touch the mechanical limitation. So if the need is there, when the limiter is active, they are only allowed to deflect to an electrically controlled maximum position. So there is a safety. Basically, if for instance an engine driven pump shaft is broken, the limiter could be helpful. However, it is recommended to contact MAN B&W diesel if situation like this should occur. At risk of the mechanical overload, cancellation of the pump torque limiter must only be selected when it has confirmed that the engine driven pump is not working. If the engine driven pump is not working, then only you can that cancellation you can do, because you will have to use your electrical driven pump to run the engine. Set point and hydraulic oil. Adjustment of the oil pressure set point can be done from set point display. where the actual set point is always shown. Now we are coming to the set point of the hydraulic oil. So set point of the hydraulic oil I discussed already, I think. Which screen? Yeah, this is the screen. So you press the set point. Adjustment of the oil pressure of the set point can be done from the set point display, but the actual set point is always shown. The engine must be running. The actual oil pressure is shown at the display as hydraulic oil. Adjustment of the set point, that is the chip level and manual mode, is only intended as an option in test or failure situation. As default, the normal operating pressure is in the 200 to 300 bar range and is set at commissioning. The engine shutdown level is approximately 140 to 180 bars. So below 140, in case of if it is a 200 bar system, below 140 engine shutdown will happen, and it is 300 bar system, below 180 bar the engine will shut down. So both operating pressure and the shutdown pressure is engine dependent. The pressure set point is only relevant for the engine driven switch plate pumps, as the pressure of the engine startup pump is limited via mechanical adjustment pressure limiting valves. The startup pumps are automatically stopped at normal engine running. Now we can see something as double pipe, where 1 to 1 121 bar is displayed. Now this display shows the pressure in the outer pipes of the high pressure double pipes. Normally this pressure should be in the region of 0 to 10 bar range depending on the specific engine layout. Now why this bypass valve is given, guys? The main pressure line from the engine driven pumps, a bypass line is installed. Now at normal running with the SPS mode in auto, the bypass will open in the event of shutdown of the engine, because if after shutdown of the engine also the engine keep on windmilling, that is the propeller continue to turn, and in that case the attached pumps will also be running and they will deliver, because these are positive displacement pumps, so it will continue to deliver oil, but this oil is not being consumed in the fuel booster unit and exhaust gas unit, so ultimately it will overpressurize the line and the line may rupture in the delivery side. So this ensure oil return is very much required from the output line of the pump, delivery lines of the pump. So this ensures oil return to the suction side of the pumps and thereby avoid cavitation and unintended wear of the pumps parts. Also, if the shutdown is due to leakage at the high pressure side and the engine keeps turning due to sometimes the shutdown happen due to oil pressure falling, how this if there is a leakage also, the oil pressure, the servo oil pressure will fall down and engine will continue to turn due to windmilling, and this time the pump will continue to deliver oil to the delivery side, and all the oil will go outside due to leakage. So this amount of oil spill can be reduced by leading the oil back to the suction side. So that is another advantage of this bypass valve. By checking the valve manually, you are always sure that the valve is working properly. The valve is to be checked manually every 6 months. The bypass valve is tested at the engine still stand in chief level and the SPS mode in manual. For redundancy reasons, the bypass valve is controlled both via auxiliary control unit 1 and auxiliary control unit 3. Now guys, I'm going to the other slide, that is the scavenger. Now we are on the screen for the scavenger. The scavenger screen contains information and controls for monitoring and operating the auxiliary blowers, exhaust gas bypass, and the variable turbocharger system that dependent on the engine type. The blowers are normally operating in auto mode. Operating conditions are: the blowers are started when prepare start button is pressed. So we have seen earlier, when you press the prepare start button, two things will happen. It will start the auxiliary blower and your electrical driven pumps for servo oil pressure, that will start. Maneuvering handle is moved to the start position. Engine start is delayed until the blowers are running and pressure is. Suppose blowers are in start position and you don't press this prepare start button, but immediately you shift this maneuvering lever to the start position, the blower will start. It will take time, but the blower will start and the servo pressure will be there. It will stabilize, then only the engine will turn. Engine is running but the scavenger pressure is below a certain value. Suppose the blower will start. When the blower will start, engine is running, but if the cutoff pressure is not achieved, then until unless the blower will run. The blowers are stopped when engine is shut down. Which all condition the blower will be in stopped condition? When the engine is in shutdown, when the current sub telegraph command state is moved to the finish with engine position, and 10 minutes after the engine has been stopped. And generally if you keep the engine stopped condition but finish with engine command is not given, so after 10 minutes running the blower will stop on its own. Engine is running and the scavenge, suppose the engine running but the scavenge air pressure is not sufficient above a specified value, then the blower will also run. If a switch to if you can switch this blower from auto to manual mode also, and manual mode you can continue to run this blower, or this is done by pressing the blower mode push button. The blower mode you can see here, it is showing auto. You can press it and the two button will appear, manual or auto. You can change it and then you can set it. Then exhaust gas bypass and variable turbocharging system. Monitoring of the exhaust gas bypass system and variable turbocharging systems is performed from the scavenger screen. The actual positions and settings of the on-off bypass, the variable control bypass valves and variable systems are always shown on the screen. The pressing the bypass mode push button in the chip level, the bypass valves modes can be changed between the automatic and manual, so you can do it. And the manual mode chip level, the variable control bypass valves can be opened, closed or set to the desired angle. In manual mode also the on-off bypass can be opened or closed. So for detailed description the variable turbocharger system and exhaust bypass system, see separate manuals. Now guys, I am coming to very important slide that is called cylinder lubrication. So cylinder lubrication, the ME loop control system provides the operational monitoring and control of the ME cylinder lubrication plant, which lubricates the cylinder in the ME type engine. Now the following displays can be monitored, that is the flow, liter per hour, basic feed rate, gram per kilowatt hour, and actual feed rate, gram per kilowatt hour. The flow. So in this screen at the topmost side left hand corner you can see the flow display shows the ordered lube oil amount in liters per hour. Here it is showing 47.0 liter per hour. One or more lubricators are malfunctioning, that is because of the feedback failure and all. The actual amount whatever showing here may be differ from the actual amount. The basic feed rate. What is the basic feed rate? The basic feed rate is a calculated rate for the complete lubricator system in gram per kilowatt hour, shown in 2 decimals. The formula for calculating the basic feed rate is nothing but the rate is basic feed rate is equal to sulfur percentage into feed rate factor. So guys, we know that the feed rate factor normally for engine is 0.34 gram per kilowatt hour sulfur percentage. The actual feed rate is cylinder. The bar graph for each cylinder, each individual cylinder shows the actual feed rate per cylinder after the influence of the limiters, load control, etc. If the feed rate due to the low load exceeds the maximum display capacity, that is 1.45 gram per kilowatt hour, the full bar is barred and the upper display on the bar graph shows low load. Now in this screen we can see the total lube, that is the pre-lube, LCD, sulfur percentage, feed rate factor, minimum feed rate adjustment factor, running in and lubricator test sequence. Now what is total? Total display shows the total ordered amount of lubricating oil used since last power up of the ECU involved. So guys, last time when the engine was started, from then it is continued to run, and how much total cylinder oil has been consumed, that we can see from this total in liter Both of the values, flow and total, are based on the counter numbers of the lubrication strokes and displaced amount per stroke. So this is generally calculated from the theory or formula, say that is the displaced amount per stroke and the lubrication stroke. Now pre-lube for test purpose, this button is only used for test purposes. When the pre-lube button is pressed, the toolbar is shown in the screen. If you press this button on, triggers a pre-lubrication on all cylinders and evaluates feedback from the lubricators. As default, each lubricator is activated 20 times at the fastest possible speed. Now pre-lubrication can only be activated if the hydraulic pressure is present. So guys, your electrical driven servo oil pump should be running in this condition. This demands that the engine is put in the state standby or that the hydraulic stud pumps are set manual operation. So LCD, what do you mean by LCD? The LCD display shows whether the LCD load change dependent lubrication is on or off. Then sulfur percentage, activating the display sulfur percent enable the adjustment of the sulfur content equal to the sulfur content in the SFO used. The principle of how to adjust the feed rate according to the sulfur content is explained in the section 70702 in this book. The range is between 0.0% to 5% sulfur range, not adjustable outside this range. Now feed rate factor, what do you mean by feed rate? Activating the display feed rate factor enables adjustment of the feed rate for all cylinders. The display shows the feed rate with 2 decimal and that is gram per kilowatt hour percentage. Minimum feed rate. The display minimum feed rate enables the adjustment of the minimum feed rate for all cylinders. The value is displayed in gram per kilowatt hour and normally set to 60% of the basic recommended feed rate. Feed rate adjustment factor, activating the display feed rate adjustment factor enables adjustment of the feed rate for each cylinder separately. Running in gram per kilowatt hour, when a single cylinder is being run in, the feed rate is adjusted on this display. Running in of a single cylinder is described in section 70701 in this book. Now lubricator test sequence, pressing the lubricator test sequence starts a continuous activation of the lubricator at normal injection rate, different from pre-lube, and injection of oil is done 20 times at the fastest possible speed. This feature is used after repairs. It is on the lubricator, enabling the engineer to manually check the lubricator for leaks and injection. If a single bottle cylinder 1, 2, 3 etc is pressed, a toolbar is shown on the screen. The toolbar enables the engineer to start lubrication on the particular cylinder concerned or on all cylinders. So guys, the lubricator test sequence can be performed for individual as well as all the cylinders, but the pre-lube, this button is used only for all the cylinders, and during the starting of the engine this is done, and lubricator test sequence is done only for single unit. So if after maintenance we can press this lubricator test sequence for a unit where the maintenance has been recently carried out, the lubricator test can only be activated if the hydraulic pressure is present. This requires that the engine, that is the telegraph, is put in the state standby or that the hydraulic starter pumps are set at manual operation and started. Now guys, I am going to another slide that is very important, that is the maintenance. So under the maintenance we have system view, input output test, invalidated inputs, network status, function test, and troubleshooting. So here in this screen you can see the above mentioned 5 maintenance screens can be accessed via the secondary navigator by pressing the maintenance button in the main navigator. They are mainly used at engine commissioning, during fault finding, and input output cabling, channels and external connection to the sensors, and during engine operation. The use of these screens is therefore relevant for engine crew as well. So I press the system view input output test button and I get this screen what you can see right now. To understand the use of this screen, an explanation of the layout of the multi-purpose controller is appropriate. Now we want to know what is multi-purpose controller, guys. This is very important for M engine. The multi-purpose controller is a computer unit which has no user interface such as a display or a keyboard, but has a wide variety of inputs outputs for interfacing to sensors and actuators of the engine. Input for that is tacho signals, standard 4 to 20 milliamps transducers, plus minus 10 volt signals and switches, and 24 volt binary signals. Now these are the input. What are the input given? 4 to 20 milliamps, that is coming from the transducers, plus minus 10 volts input voltage signals, that is, and also switches, and 24 volt binary signals are given. Output we have again 4 to 20 milliamp signal, plus minus 10 volt signals, contacts and high speed semiconductor switches for activation of the exhaust valve of the ME engine, for instance. Duplicated control network for security, serial communication controller for either a remote input output network or point to point serial communication, service channel to be connected to a laptop PC or service purposes. Okay, so the main purpose of the multi-purpose controller is a Motorola 68332, which is a 32-bit processor, and it was borrowed from the automotive industry. That is very interesting. So guys, this multi-purpose controller was basically belong to the automotive industry, and the shipping industry, they have borrowed it and made this ME engine. So it includes an on-chip timing coprocessor for the synchronization with the crankshaft rotation and speed measurement. So on-chip timing coprocessor for synchronization with the crankshaft rotation and speed measurement. To ease the production of the multi-purpose controller, all programmable components are in circuit programmable, which also allowed field update of the controller by means of relatively simple tools. The multi-purpose controller contains no hard disk or other sensitive mechanical components, and the software is stored in a non-volatile flash PROM memory. That is, the application of the software may be sent to and programmed into the multi-purpose controller through the network, and thereby restore the functionality after the multi-purpose controller has been exchanged with a spare unit from the stock. The multi-purpose controller is equipped with a battery. This battery is used for backup power to the clock, and it is a watch of the multi-purpose controller in the event that the 24 volt power is turned off. So this inbuilt battery will still supply the power and continue the clock. All clocks of all multi-purpose controllers are synchronized via the network. Synchronization is done regularly and always after power is on, after a possible power off. So you have to do synchronization after this is a power failure. So guys, you need to do this synchronization. Regarding battery MPC, now when a new MPC is mounted in the cabinet, the dongle in the cabinet is mounted in the dongle plug-in. So there is a plug-in for the dongle plug-in, and after reconnection of all wires, the dongle tells the new MPC in which cabinet it is mounted, and in that way which software and parameters it should upload from the MOP hard disk, that is CCU1, ACU3 or EICUA. So the MPC is also equipped with a light diode capable of showing green, yellow or red light. So I will tell you the significance of these lights. This light tells the engineer in what status the MPC is. During normal running, the diode is green. Suppose it is green, there is no need to be worried, it is alright. When the diode is yellow, the MPC is downloading the software from the hard disk, that is the MOP, or is in the test or configuration mode. When the MOP is in the test or in the configuration mode, yellow light will be lit. So guys, no need to worry about this also, and normally this takes a few minutes. When the diode is now only thing is that when the diode is red, the MPC is unavailable. That means there is a problem with the MPC and MPC is unavailable in case the this diode is red. The use of the screens on the plates 70332 that become relevant when the MPC change is to be done. Detailed LED, the slide out indications are shown in the maintenance procedure. Now we will go to this invalidated inputs. So guys, below this system view input output test invalidated inputs. If an input channel is invalidated, that is described in section 1.1 above, it is listed on the screen invalidated inputs, that is ID number. So this is system view input output test. The second screen goes like this. This is all about, and that has this is system view input output. Say a single channel is selected, then the screen comes like this. Then system view input then you can invalidate. If you select some channel, you can invalidate it. If an input channel is invalidated, it is listed on the screen invalidated inputs. It has got ID number and signal ID and short description. To easily overview and recognize the channel involved are shown on this screen. The invalidated input screen is a quick view helping the engineer look through and control the channel to invalidate, and could be helpful for instance after an MPC change. Input channels invalidated can be validated from the screen. So validate, invalidate, that can do on a particular screen. If you click on this process values, suppose we are doing that is LFE or FIVA feedback signal fail, we select this. The signal ID is 4102. This description LFE and FIVA position feedback, where we get in the yellow signal there's 0.0 milliamps and the channel is invalidated. Now we press again and we can go back to the validate again. So we can do like this. So invalidate inputs, the whatever channel we do invalidate, that will be shown in the invalidated, this list will come and you can view that. Now you can see the network status. If you go to the network, this screen gives the engineer and overall view and exact status of the control network of the ECS engine control system. From this it is possible to see the status of the network using the icons visible, that is this MOP no reply, single channel, no communication, not accessible, online but no information, not relevant, reference, cross connection, whatever it is, this all this we can see what has happened with the network. Now when all fields are shown with a green and tick mark is given, check mark, everything is okay. Otherwise the use of this screen becomes especially relevant when the manual checks for earth fault is performed. Manual check for earth fault is performed, this screen become very useful. Now guys, go to the function test. So okay, this screen, suppose under admin set time, press the set time and then you go and you can see pop-up window appear, local date time. So here you put new date and time by these buttons and then set it. So you can go to the UTC time displayed and the local time displayed and set it, and new time will be set. And these are the function test. So this screen is very important guys. Again, the function test tab consists of 3 items. The submenus, there is ACU, the hydraulic control unit for each cylinder, the tacho equipment and the SPS for each pump. The main purpose of these 3 screens is to provide the engine personnel with a tool to test the function of the ACU, SPS and tacho equipment. and the related components. Also, the function test screens are used when the replaced components are to be calibrated. In case of replacement of a fuel plunger sensor, that is to be, suppose when we do this function test, we do any maintenance and we don't want to start our engine, or there is no we are in port and we cannot start the engine. In that case, we can do this function test to calibrate or to understand the components which has been recently changed or maintenance has been carried out, that is working fine or not. The function test screens are made as a step-by-step procedure guiding the engine personnel through the test. Each test begins with a few preparation steps in order to ensure the right conditions before commencing the actual test. The MOP must be in the chief access level, and if not otherwise stated, the engine must be stopped before commencing the test. So better to test in the engine stop mode only. This function test shall be carried out. Note, when rebooting an MPC in the test mode, multiple alarms irrelevant to the test may occur. So when you put this MPC in the test mode, multiple alarms must occur. You no need to worry about that. You can acknowledge that. Now we go to SCU. If you press this, so guys, on that, when you press this function test, you can see these three buttons appearing on the top. Horizontal, you can see the SCU, TACO and SPS. So you press SCU tab focusing on the FIBA valve. Depending on the configuration, the list contains 3 or 2 function tests. Only the FIBA valves with external amplifier have the option of an amplifier test. In the following, all 3 function tests are explained. Preparation of the SCU test. To begin with the function test, press the button start and follow the steps on the screen. In order to verify that the fuel booster or exhaust valves are functioning as expected, an assistant must be stationed on the engine top at the unit in question during the test. Now B. Test of the FIBA valve and calibration of the fuel plunger. If the CCU MPC is not in the test mode, when the start button is pressed, the engineer is prompted to switch to the test mode and reboot the MPC. Once the MPC has been rebooted, the function test will continue. So guys, what is happening? Test of the FIBA valve and calibration of the fuel. If the CCU MPC is not in test mode, when the start button is pressed, the engineer is prompted to switch to the test mode and reboot the MPC. When they reboot the MPC, then test procedure will continue. For testing the fuel injection components, the FIBA will make one fuel injection. This is verified by the assistant on the engine top by feeling the shock wave on the respective fuel injection pipe. For testing the exhaust valve components, the FIBA will activate the respective exhaust valve once. This is verified by the assistant by listening for the thump sound of the exhaust valve opening and closing. The test value is listed on the blue background in the far right column when the function test is finished, and will under normal circumstances be within the default reference range listed next to the test value column. If for some reason the test value differs from the reference value, this will shown one of the following way, that is x dot xv. So signal value is okay. If dot dot dot, dash dash dash, there are 3 dash in red background, the signal not present, then check the MPC is connected to the network or not. There is any connection problem, loose wire or something has happened. So a red and in that is rectangular shape will appear when this dash dash dash. And if red and x dot xma that is appearing in red, this means the signal value outside the reference range, value electronically out of the range and wire break or something like that has happened. And if it is in yellow, x dot xv, then the signal value outside the reference range, signal okay, unit mechanically out of range. Then we can do the cyclic test of the exhaust valve. So that is available, guys. Now we will go to the this one is very important, that is the troubleshooting. You can go to the troubleshooting, and guys, I would like to discuss this screen is used if you press this troubleshooting button. Under troubleshooting you have SU, SPS, SU events and SPS events. Now SU on this screen, FIVA activation can be performed to execute the fuel plunger and exhaust valve movement to check whether the system is working correctly. The activation must only be performed with the stopped engine. Each activation of the fuel plunger result in a fuel injection into the cylinder. So activation of the FIVA is performed by changing the MPC mode into the test mode. So MPC mode, if it is normal, you have to change it, to press it, then change it to the test mode, and activating the buttons displayed in the toolbar. And the cyclic test is only a cyclic activation of the exhaust valve. Now SPS, if you press the SPS, so fuel oil plunger inject, return, exhaust valve open close, and cyclic test can be carried out with this screen. Now next screen, SPS same thing, that is this screen also inject, return, that is shown. And now in this screen, exhaust valve open close done. This screen guys, SPS, where you can see on this screen the swash plate position for each pump can be regulated to check whether the system is working correctly. Activation of the swash plate position is performed by changing MPC mode into test mode and activating the buttons displayed in the toolbar. The swash plate position can be seen on input channel 34 and compared with the desired set point. So this you can do. Then SU events or SPS events, these screens are an aid for the engineer and are used to monitor the actual movements of the SU and SPS over time, and that is used to identify the trouble in case of a malfunction of the electrical or mechanical components. A list of dumps can be found in the upper left part of the list. To display the content, mark and element in the list and press the show sequence. So show sequence, if you press this, list will appear. Both manual dumps, that is log manually, and the automatic dumps can be performed for special failures or alarms. The event which caused the dump is described in the text above the graph area. The time of the alarm is shown as a vertical dashed line. The display of the measured values can be turned on and off by pressing the buttons on the left side of the screen. Furthermore, the measurements can be displayed both as a function of the time and angle. So these are the things very important. See this screen. So this one again, the SPS, where we can see we can swash plate position set point. We press the position set point, and we have to change this MPC mode to test mode and activate. And after that, if we press this swash plate position, in percentage it is showing 16 milliamps and 20%. So we have a current value and new value. We will put the new value 30%, and then we put by this up and down button and press the set button. The new value should appear. That is how we know the system is working. Command is going. So guys, this is the system. This is all about the MOP. Hope you have enjoyed this session, and it will be helpful for your vessel. So guys, thank you.